So we have to calculate, find the maximum value of force F acting on block M1 for no slipping between the blocks. Okay, this is the condition given for us. Where the force is applied to the upper block. So maximum value of force F for which no slipping occurs between the blocks here. We had this particular numerical we did for only 2 blocks. Now we have to extend that concept for 3 blocks. First, let's calculate the various forces that are acting that one. The normal reaction will take it. So this will be N1, the weight of this, and here N1. M2G, and this will be N2. This will be N2, M3G, and this is N3. First, we'll calculate these values because they are needed for us for the calculation of friction. Now, looking at the first block, N1 should be equal to N1 minus M1G equal to 0. N2 is equal to N2 minus N1 minus M2G 0. So therefore, this should be N1 is equal to M1G. What is N2 is equal to? M1 plus M2G. Then N3 is equal to N3 minus N2 minus M3G equal to 0. Substituting value of N2, I'll get this is M1 plus M2 plus M3G. Like this, we'll get the normal reactions. Let's calculate the limiting frictions at surface 1, 2, and 2, 3. What is F1L? Now, before jumping into problem, I think we should have the limiting frictions, to cross-check whether what we assumed is right or wrong. So they should be equal to mu N1. Value of mu 0.5. N1 is 10, so 5 Newton. Similarly, limiting friction at second and third surface. This should be equal to mu N2. 0.5. What is the value of N2 will be? M1 plus M2, 40 Newton. This will be how much? 20 Newton will be F2L. I think these values are very important. In all our numericals, we'll be taking help of this data. Now, how to get the direction of friction? How to get the direction of friction? Initially, they are at rest. So when we apply a force F, so all the blocks are at rest. When I apply force F, the block M1, what happens, starts moving. No, it will overcome inertia of motion. But what about M2, M3? They will try to retain inertia of rest, but because friction will active. So definitely the M2 will oppose the motion of block M1. So therefore the friction should be like this. Similarly, the force will always occur in plane, the friction like this. This friction force, which is acting on the block M2, will try to shift the block M2 towards right, whereas M3, what happen, will oppose it. So what direction the friction by M3 on M2 should be? Should be in this direction. Then F2 should be like this. Okay, got the idea now how to get the direction of friction? No. Okay, after this, we have to, what was our goal? To find out the maximum value of frictional force. Okay, now let's ask a very logical question. So let's go back to the basic concept. As I keep on increase applied force, what conditions were arised? Then at one particular point, the slipping used to occur, no? Here I'll keep on increase this applied force. Then where the slipping will first occur between M1, M2 or M2, M3, we don't know that. I am asking you pinpointedly one question. With that only you can manage this particular numerical very easily. I'll keep on increase applied force. Then the friction, static friction, both at F1 and F2 will increase. Then when maximum force when I apply it, where the friction will be limiting at 1, 2 or 2, 3 or at both, three situations are there. Because when you apply maximum force, so where do that particular slipping will occur?
At 1, 2.
You can't make a guess. You're supposed to solve problem, no? You should not make a guess. Everything has to be derived. Just by making guess is the wrong thing. We are supposed to analyze. So therefore, first what will happen? I'll do one thing. Total force acting on the system. Let me directly go for acceleration of system. So what are the equations we can write it? F minus. Let's assume that no slipping occurs at all surfaces. Accelerations, I'll give accelerations. Let A be the acceleration. Then this should be equal to M1A F minus F2 equal to M2E, then F2 equal to M3. If you add up all this, what is the acceleration you'll get? F by M1 plus M2 plus M3. What is the value of M1 plus M2, M3? So this will be 6, F by 6 I'll substitute. After substituting the values, 1 plus 3 plus 2. I'm ending up this one. So what is the acceleration equal to? F by 6 here. Next, what I do is like, I will straight away substitute. These are the equation 1, equation 2, equation 3. What I got, this is equation 4. I'll substitute equation 4 in 1. Substituting equation 4 in 1. The initial background. This much is what I think everyone you can manage. Here is what you have to analyze the problem. So I'll substitute the value of put 4 in 1. Let's end up with one equation. F minus F1 equal to, what is the value of M1? M1 is 1. This will be F by 6. So F minus F by 6 equal to F1. So what is F1 is equal to? 5F by 6. As I keep on increase applied force, what will happen to F1? Will also increase. As I keep on increase applied force, the frictional force at 192 also will increase. So what is the maximum upper limit for F1? F1L. So this is what I'm making guess. I'm just trying myself. Either I'm right or wrong. That's why I just put a one line. I'm going to split up this problem into 3 parts. This is the initial part. The first one I'm making I'm assuming one situation. What is that? As I increase the applied force and one specific value, first I say that slipping occurs at 192. Slipping occurs at 192 means what happens? There should be limiting friction. So therefore here, this should be when the applied force becomes maximum. Then what about the friction here? Will be F1L. What is F1L equal to? 5 Newton. So this will be 5 is equal to 5 by 6 into F max. So F max I got 6 Newton. Is I'm right? So this what is I'm right? I have to check it. So therefore what I'll take help of the block like a M3 that one. If you apply force of 6 Newton. And don't blame me, sir. Why don't you give one formula so that we'll substitute, we'll get answer. I think that particular way of physics long back it's over. Now when I apply maximum force, So what is the condition now? Here I assume that FNL, I assume that no slipping occurs here. And let them move with an acceleration A. We'll calculate, what we'll do, we'll calculate this F2. If this F2, what will happen, was less than F2L, then what I assumed is right. Got this? So what is the, if you apply 6 Newton force, what will be the acceleration of the system? I'll slide down. What is the acceleration of system? Acceleration equal to F max by, because everything, all the friction force will become internal. M1 plus M2 plus M3. So this should be equal to 6, 1 plus 3, 2. This is equal to 1 meter per second square. Let's calculate F2 value. F2 is equal to how much? F2 is equal to M3 into A. So this A dash, I'll call it. So some of you will confuse with that A. Let me call A dash. Now, what is value of A? What is value of M3? 2, no? What is acceleration A dash? 1. Look at now. I am getting 2 Newton. Look at now, what is F2L? 20 Newton. But how much it is acting? 2 Newton, which is less than F2L. So what I assume now is correct, no? What I assumed is correct. So therefore, what is our maximum force for which no slipping occurs at any block? Means, sorry, I'll apply 8 Newton. Then slipping will occur at 1. But slipping will not occur at 2, 3. So therefore, what is our answer now? Our answer should be 6 Newton. Okay, now the problem begins like this. Sir, you assumed first that no slipping occurs at 2 and 3, then will happen at 1, will happen there about to slip, then you calculate F max. What happens if student assume that no slipping at 1, 2 and slipping occurs at 2, 3? The student may go like that also, no? Then you will get one answer. Then which answer will be correct? Okay, let's see that one. So what I'm going to do is like, I'm going to assume now, I'll put equation 4 in 3. Put 4 in 3. So what is equation 4? F3 equal to M3 into A. I'm substituting that one. So in place of, so when I substitute here, how much I'll get? F by 6. And what is value of M3? 2F by 6. So therefore, finally, how much will get? This F is equal to 3 F3. So I increase now the applied force, the frictional force. What is the maximum permitted value of? This should be F2, no? What is the maximum permitted value of F2? What is the maximum permitted value of F2L? So when 3 into F2L. So what is F2L value? F2L is 20 Newton. Please, don't repeat. So 60 Newton, I got it. Okay, now earlier I brought 6 Newton, no? Now I brought 60 Newton, then which is correct? Let's check it. Now I'll go back to the thing. I'm going to apply that 60 Newton. What is the assumption? I applied 60 Newton on this. Then here the friction acting, I'll assume static. Then here what will happen? It should be limiting friction. The acceleration, let me call A double dash. What is A double dash? Should be equal to F max by M1 plus M2 plus M3. This will be 60, 1 plus 3 plus 2. I'm getting this 10 meter per second square. Let's calculate the friction F1. Then this should be equal to F max minus F1 equal to M A double dash. What is the F max value? 60 Newton. F1 I don't know. M1 is how much? 1 kg. This is 10. So F1 equal to 50 Newton I'm getting. But what is the maximum permitted value of F1L? 5 Newton, no? No, is it friction possible? Is it friction? Can it be greater than limiting friction? Not possible, no? So therefore, not possible. What went wrong? When we applied maximum force, there was slipping between M2, M3. That assumption was wrong, no? What was the assumption? What was the assumption? For F maximum, slipping occurs at M2 and M3. Just slipping occurs. Or limiting friction, or the slipping again you'll get confused. For F max, limiting friction acts at M2 and M3, and static friction acts at M1 and M2. This was our assumption. But is it, did we got, look it clearly? What we assumed, this was the assumption we made. Is this assumption correct? No, went wrong, no? Assumption is not true. Okay, so finally, will you write 6 Newton or maximum force for which no slipping 6 Newton or 60 Newton? Please do clarify. This is the first problem. You can understand this, you can manage. Rest all, what all I ask, very easy for you. So what shall I take answer? Shall I take answer 60 Newton or 6 Newton? No, 6 Newton only, because what we assumed is wrong, no? Assumption is not true. In fact, what will happen? The friction what happen at 1, 2 happen should be static, but what we got, it was greater than limiting friction. So the assumption went wrong. So therefore, this cannot be the answer. This cannot be the answer. Are you getting now this one? So whenever if they ask you maximum force now for more than 2 surfaces, this is the one. So what you should do, assume at one surface slipping, at other surface static friction, check it. If other surface where you assume static friction less than limiting, what you assumed is right. Just some, you can say logical analysis what we are supposed to do here. Anybody, any doubt, you can clarify.
Sir, in the first case, F2 should balance F1, right?
F2 should balance F1. There you apply force, the system is accelerating, no? How they'll balance?
Sir, if we apply a force that is less than maximum value of static friction, then static friction will balance that force.
I don't know, you have to, some simple idea. We applied a force. What is the net force acting on the system? Only F max, no? What is the state of M1, M2, M3? Accelerating, no? So now where is the question of rest of any block? All the blocks will be moving.
No,
All right.
for mass M2, sir.
Mass M2 only. See, like if M1 accelerates, then M2 should also accelerate, no? M3 should all blocks are accelerating. All blocks are moving.
Between M1 and M2, there will be static friction. There is no relative motion.
See, if M1 moving, then M2 should also move, no? With respect to ground. So all the blocks are moving. I don't know, the very question itself, what happened, you are taking in wrong direction. When I apply that 6 Newton force, all the blocks are moving, then what happened? at maximum force open, at M1, M2 open limiting friction will act, and F2 will be static. What is M2? Why M2 will be at rest? M2 is also moving, no? You can see F1L greater than F2. Check it. What is F1L?
So then it is not static friction, and it is static friction.
F2 is a static, no?
So if
F2 will.
F1 is less than F12, then F2 should balance F1, right?
Hi,
To match that value.
are you not looking at acceleration, my dear? Look at acceleration. What is the state of M1, M2, M3? They're accelerating. So what makes M2 to accelerate? F1L should be greater than F2, no? What is the value of F2? Look at here. I think all the data is there. Something you got stuck with some idea. Come out of that one. F2 is how much? 2 Newton. F1L is how much? F1L is how much? 5 Newton. So 5 Newton is greater than 2 Newton. Yes. So M2 will accelerate.
So if they are accelerating, that means they move, right? So if they move, it is static friction only, right?
Oh, gone. I don't know. Like everything, what all I thought you put in dustbin. Huh? You go back to the basic ideas. When there is no relative motion, when A relative 0, friction acting is static. When A relative non-zero, friction acting will be kinetic. I think I have to write once again. Huh?
Sir, if it is static, then static will adjust itself when we apply a force, right? So
Please listen to me. Analyze, then you can talk. Huh? If A relative 0, blocks will move with same acceleration. Friction acting blocks, if A relative 0, blocks will move with same acceleration. Friction acting or static friction acts. I think yesterday this is what I tried my level best to impart, no? Static friction acts here. If A relative non-zero, then blocks move with static friction acts or no slipping occurs. A relative non-zero, blocks move with different acceleration, kinetic friction acts, and slipping occurs. We are not discussing a block kept on a ground. We are discussing about the two blocks. No, I think this is you have to come out of the first, the topic of friction. Here we are discussing about the block upon a block. For a block on block, I told you we are going to encounter a different situation. If A relative 0, friction acting will be static and no slipping occurs, and blocks will move with same acceleration. If A relative non-zero, if the relative acceleration, then the friction acting will be kinetic. So static means the block should be at rest, need not know. There's not a necessary condition. We have discussed actually so many problems.
So if static friction exists between M1 and M2, then it should balance that force F1, right?
I don't know, Pa. Yesterday we have discussed so many things. Yesterday you were absent or present?
Present.
Then yesterday's discussion, I'll take it for you. You are supposed to revise yesterday's things, no? Without revising that, coming to the class. Without revising.